What is a differential equation? It is an equation involving derivatives. Okay, for example, d square y by dx square plus 4 cos x plus y is equal to 3. It is a differential equation because it involves derivative, second order derivative d square y by dx square. Now, there are two terms associated with every differential equation, that is order and degree. Order and degree of a differential equation. What is order? It is the order of the highest order derivative occurring in that differential equation. So, if you look at this equation, we have second order derivative is present. d square y by dx square is present. That means that order is 1. Order is 2 because second order derivative is present in it. Now, if you consider another differential equation, if it is d cube y by dx cube whole square plus dy by dx whole raised to 4 is equal to 3y. Then what is the order of this differential equation? There is third order derivative occur. D cube y by dx cube is present. Therefore, order is 3. Okay. Now, what is degree of a differential equation? It is the degree is the degree of the highest order derivative occurring in the differential equation, provided it's a polynomial equation. That means there is no fractions in derivatives. Okay. There is no negative power, things like that. It's a polynomial equation. So, what is degree of this differential equation? Degree of this differential equation is it 2 or 4? So, what you have to look at is, look at the highest order derivative. D cubed y by dx cube is the highest order derivative. What is its degree? It is 2. So, degree of this differential equation is 2. Whereas, what is the degree of the first differential equation? D square y by dx square is the highest order derivative. Its power or degree is 1. So, degree of that differential equation is 1. Now, we are here to find the solution of a differential equation. What is the solution of a differential equation? It's a relationship between the two variables x and y satisfying the given differential equation. There are two types of solutions for a differential equation. They are called general solution and particular solution. What is the difference? General solution of a differential equation is the solution involving any arbitrary constants. The number of arbitrary constants is equal to the order of the differential equation. If it is a first order differential equation, there will be one arbitrary constant in the solution of the differential equation. The particular solution is the solution obtained by giving particular values to the arbitrary constant involved in the general solution. Okay. Now, when you go to the solution of a differential equation, we are going to find the general solution of a differential equation. There are three types. The first type of a differential equation, that is variables separable form. Variables separable form. What is variable separable form of a differential equation? Okay. So, a differential equation of the form dy by dx is equal to a function of x and a function of y are multiplied together. F of x is a function of x alone, g of y is a function of y alone. Or we can even write this is equal to dy by gy is equal to f of x into d of x. Function of x along with dx and function of y along with dy. Then this is called variable separable form. Y variable is in the left side, x variable along with dx is on the right side. Then what is the general solution of this form of variable separable form? The general solution of this is given by integrating both sides, Simply integrate both sides, you will get the general solution. So integral dy by gy is equal to integral fx dx plus c. That is the general solution of the variable separable form. Simply integrating both sides, we get the solution. Now, second, we go to the second type of the differential equation. The second type of the differential equation is called a homogeneous differential equation. Homogeneous differential equation. There are two types of homogeneous differential equations. In that, first type is dy by dx is equal to a function of x comma y, x and y combined. But this fxy is something special. Fxy is a homogeneous function. F of xy is a homogeneous function of degree 0. What is a homogeneous function? Degree 0. That means if we replace x by lambda x and y by lambda y, f of lambda x comma lambda y will be equal to lambda raised to 0 into f of xy. So that is called a homogeneous function of degree 0. Okay, this is how we will identify homogeneous differential equation. Now, after identifying the homogeneous differential equation, how to solve it? In order to solve it, solution. We are going to convert it into the variable separable form by a substitution. What is a substitution? It is y is equal to, replace y by vx, where v is a function of x. Okay, so replace y by vx, then what will be dy by dx? Differentiating both sides, dy by dx is equal to v into x. V is a function of x, apply product rule, v into derivative of x, which is 1, plus x into derivative of v with respect to x. So replace dy by dx by v plus x dv by dx, and wherever y comes, replace it by y vx. Then what happens is this given homogeneous differential equation changes to variable separable form. Our homogeneous differential equation changes to the first form, variable separable form, in which there will not be any y term, v terms along with dv and x terms along with the dx. That means it will be changing it like this: f of v dv is equal to some g of x dx. So changed into variable separable form, then solution will be this integral is equal to this integral plus c. Okay, so this is the first type of homogeneous differential equation, that is dy by dx is a function of x and y, f of xy is a homogeneous function. Now under that we have a second type, that is dx by dy is a homogeneous function of x and y of degree 0. Homogeneous function of degree 0. In that case, what is the substitution? In that case, substitution will be, we are substituting for x. X is equal to vy, and we have to replace dx by dy. What is dx by dy? Differentiating this, we have v plus y into dv by dy. So by this substitution, our given differential equation again changes to variable separable form, in which v terms on one side and y terms on the other side. So it is changed into variable separable form. Integrating both sides, we will get the solution of the differential equation. That is the second type, homogeneous differential equation. And finally, we have the third type, that is called linear differential equation. Linear differential equation. What is a linear differential equation? There is a particular format, that is y and dy by dx occur, they will be in linear form, and they are never multiplied together. Dy by dx plus py is equal to q, where what, there is a dy by dx term, there is a y term. What about p and q? P and q they are either constants, they can be constants or functions of x alone. So functions of x alone, p and q are functions of x alone. Now, how to find the solution? To find the solution, we have to find a factor called integrating factor. What is integrating factor? It is e raised to integral p dx. Find integrating factor, and we have the solution is obtained using integrator factor as y into integrating factor is equal to integral q into integrating factor with respect to x plus c. That is a solution. Y into integrating factor is equal to q into integrating factor. Okay. Here also we have a second type of linear differential equation, that is, in place of dy by dx we have dx by dy plus p into x is equal to q, where p and q are either constants or function of y alone. So in that case, what will be the integrating factor? It is e raised to integral p with respect to y. And what is the solution? It is given by integral x into integrating factor is equal to integral q into integrating factor with respect to y plus c. That is the solution. Here x into integrating factor, in the first case y into integrating factor. Okay, so there are three types of differential equations, so which we can solve according by after identifying under which type the given differential equation is. Okay.